Okay. Okay, there we go. Hopefully this works. Yes, no. Hopefully this works now to some degree. All right. Well, I made a few changes, so see if it works on your other account now. It might not be your account, it just may be me. Because I made a few changes around. So okay, works. All right, good. Okay, we're all back. Are we all back? Sorry for the delay. Okay, let's that was that took a little time, but we're back, I think. Fernando, are we back? Sam? Okay. All right. All right. So let's continue moving forward then. We have just figured out y is equal to 4 minus x. Okay, let's do the other one as well. We have 4x minus 2y equals 6. All right. We're going to solve for y in this particular case as well. So we'll subtract by 4x. So we'll have negative 2y equals 6 minus 4x. And then we'll divide by negative 2. Okay, so we're going to get y is equal to negative 3 plus 2x. All right. Expand on this a little bit so we can see the whole canvas. All right. And then we're going to go ahead and make an XY chart for this. So let's go ahead and do that. So let's just plug in some numbers. 0 is minus 3, 1 is minus 1, and 2 is going to be 1. Okay, so here we got some numbers here. Okay, now let's go over the graph here for both of these lines, okay? All right, so we have 0, comma 4, and 4, comma 0. Okay, so here's the question. The question that I have is this. All right, the question I have is this, what kind of line or should we put here? Should we put a solid line or a dotted line here? Should we put a solid line or a dotted line? That's right, Fernando, that's correct. A dotted line is correct. So here we're going to put a dotted line. Okay, now the reason why we put a dotted line here is because strictly when we started with strictly less than. So because we started with strictly less than, then that means we have to use a dotted line for our graph. Let's put in the other graph here, 0, comma, minus 3. So let's put in that point. 1, comma, minus 1. 2, comma, 1. There we go. Okay, and what kind of line do we want to put between these 3 points? Do we want to put a solid line or a dotted line? Yeah, once again, a dotted line. That's correct. Okay, so here's, excuse me. So here's here's our dotted line for that. Now, as you can see here, we have 4 quadrants, 1, 2, 3, and 4. And one of these 4 is going to be our final answer. But that's why we do the 0, 0 test, is to determine what our final answer is going to be based on, what we get for the test and where we overlap. So let's take a look here at the 0, 0 test and see what that looks like. Okay, so for the 0, 0 test here, what we're going to do is we're going to go ahead and plug in 0 for x and 0 for y and see if that original inequality is true or false. So here we get the first one here, which is this is y is equal to 4 minus x is this one, and then the other one is y is equal to negative 3 plus 2x. Okay, so here's this first one. So we have 0 plus a 0 less than 4. Okay, so is a 0 less than 4? Is this true or false? Is 0 less than 4? True or false, is 0 less than 4? Okay, so the answer is true, right? 0 is definitely less than 4. So what we're going to do is we're going to shade the side that includes 0, 0. So I want you to follow this dotted line here. This dotted line reflects our first inequality, okay? That's what this dotted line right here represents. And we want to shade the side amongst this dotted line that includes the point 0, 0 since we got it to be true. So I'm going to mark that in black, all right? So I'm going to mark this in black, just like so. This would be the side that includes 0, 0. Okay, so this whole thing, I'll mark that in black. Now we do the 0, 0 test on the other part. So let's put 0, 0 here. So we get 4 times 0 minus 2 times 0 less than 6. So again, is 0 less than 6? Is that true or false? True or false is 0 less than 6? Okay, the answer is definitely true. That is correct. So you have to understand, I'm asking these questions here because we need to know which side we need to shade on. So 0 is definitely less than 6. That is true. So let's take a look at this dotted line here. So this one with negative 3 plus 2x. We want to shade the side for this dotted line to also include the point 0, 0. So I'm going to shade that in blue. Now, as you can see here, we see where they overlap. Our solution set is where both the black and the blue both overlap. That particular quadrant right there is going to be our final answer for this problem. So I'll just circle it right here. And there you go. Got it. Okay, so there you have our circled answer here. This is going to be our final answer for this particular problem. Okay, any questions about that? Would you like to do another example? Yes? Okay. Let's do another example then. Okay. Okay. For the most part, with exception to applications. So we do have an application problem to go over as well. So we'll go over that too. Okay. So let's go ahead and do one more of these type of problems here. Sure. Okay. So let's do this one here. Less than or equal to 1 and x bigger than 2. Okay. Yeah, I don't mean to, I don't mean to frustrate you today, Fernando. I apologize. All right. Okay, so here we got x minus y is less than or equal to 1. So let's go ahead and solve for y in each case, if we can. So x minus y is equal to 1. So we'll just change that inequality to equals. We'll have subtract x on both sides. What am I doing? Great question. subtract x on both sides. So we divide by -1, get -1 plus x. Yeah, I know some things happen there. Again, I still have to apologize though. At least I feel I do. So y is equal to -1 plus x. Let's go ahead and make an xy chart for that. Like I try to put out the best educational content I can. Sometimes the technology is not willing to work with me, however, some days. I always try to do my best, I promise you that. All right, we could put 1, we put 0, put -1, put -2. Okay, that seems fair. Okay, so that shouldn't be too much of a problem. All right, and we have the other one here. We have x is bigger than or equal to 2, or x is equal to 2. So that's pretty much the whole thing there. You can go ahead and just take 2 points here of 0, comma, or not 0, what am I doing? 2, comma 0. Yeah, you can plug in whatever numbers you want for x and y, as long as, basically, my idea is that as long as you can graph it, or you get like easy numbers to easily graph it on, then that's the only thing that you really need to worry about. So if you could choose easy numbers, like 0 is a super easy number. Like you don't really have to think too hard for 0, for example. Or 1 is kind of typically an easy number. So if it's easy to put on a graph, it's really not that hard to do. That's basically the kind of thinking that I put in for graphs, is like easy numbers, easy answers. Can I actually physically put it on a graph? If I can, great. Then it makes my life 10 times easier. If I got a fraction or a weird decimal or whatever, yeah, that's really not too easy to put on a graph, in either hand drawn or even on a computer. So maybe I need to pick a different number. Let's go ahead and put this graph down though. Okay, let's go ahead and try this out. We got 0, comma, -1. We get 1, comma, 0. -1, comma, -2. Okay, so now the question becomes, once again, we have to decide, are we putting a solid line here, or are we putting a dotted line here? Are we putting a solid line or a dotted line? Yeah, a solid line, right? A solid line because, again, we have less than or equal to as our inequality. I'm going to put a solid line for that one. X is equal to 2 is very easy. That's just, again, 2 values. You can just easily just kind of plop that in. There you go. Again, we're going to have a vertical line here. It'll be a solid vertical line, as Fernando has correctly pointed out. They're both going to be solid lines. So there we go, just like so. Okay, so we did the tough part, the semi-tough part there. We got the graphs, we got the points there on the graph. We know what kind of line we're going to put down. All right, now here at the end, we're going to go ahead and do our 0, 0 test to see what we get. So let's do our 0, 0 test. Okay, so we're going to take the first one here. We get 0 minus 0 is less than or equal to 1. So again, Is 0 less than or equal to 1? Is this true or false? Is 0 less than or equal to 1? That's correct. The answer is definitely true. Okay, 0 is less than or equal to 1. All right, so we're going to look at this purple line here. And we want to say this is true. So in black, we're going to go ahead and mark off the area that includes the point 0, 0. So that's all this stuff here. Okay, so that's the first one done. Let's do the next one here, which says x is bigger than or equal to 2. So it basically says this. So is 0 bigger than or equal to 2? So true or false? Is that true? Is 0 bigger than or equal to 2? True or false? Okay, so that's false. That's correct. All right, so 0 is definitely not bigger than or equal to 2. So we're going to take a look at our line here, and we're going to go ahead and put it in blue here once again. And we want to shade the side that does not include the point 0, 0. So that would be everything here. So as we can see here, what's our final result here for this? Well, that happens to be, notice that this black line here, I think let's add a little bit more here to this. So again, where this overlaps is going to be right here in this small quadrant right here. So that's going to be our answer to this problem, just like so. Is that's that very small quadrant up there based on the inequalities that we have. Okay. Right. Okay, any questions about that? Okay. Nope. Okay. Now that we have that out of the way, and we're nicely humming along too, let's go ahead and take a look here at another problem. Okay, and we're gonna do this one here together. So again, this one here just requires us to set up the problem. So we want to talk about just setting up this problem here and getting it correct to set this up. So let me go ahead and type it out here. So this is number, what number is this? Number 49 on page 460. Okay. So many elevators have a capacity of 2,000 pounds. If a child averages, I should say, averages 50 pounds, and an adult 150 pounds, write an inequality that describes when X children and Y adults will cause the elevator to be overloaded. Okay. All right. So if a child averages 50 pounds and an adult 150, right inequality describes when X children and Y adults cause the elevator to be overloaded. Okay, so let's think of it this way. The key word here, just to let you know, is the word overloaded. This is actually it will cause the elevator to be overloaded. This is actually a pretty big keyword here for getting the inequality correct. So can anybody tell me, how could we set this up here? How could we set this up where we can make an inequality where we can find out, how many kids and how many adults will it take to overload this particular elevator? So there are X children on the elevator, there are Y adults on the elevator. So how can we get the total weight of all the adults and children? No. Very funny. I'm sure there are a lot of other channels that have that. So let's think of it this way. You have X kids and Y adults on this elevator. All right, so the total weight for the number of kids that are on the elevator would be 50x. Okay, so that would be 50x for the total weight of the kids on the elevator. How about uh, how about the adults? What do you think, Fernando, Julio? All right. So in this particular case, we may get 50x for the kids, and in this case here, we get plus 150y for the adults. And for them to overload, that'll be above 2,000. Okay, so if we're going to overload, that'll be above 2,000. So we get 50x plus 150y is bigger than 2,000. All right? Okay. All right, there any questions about that, guys? Any questions? Okay. 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 All right, very good. All right, so that is the last example that I wanted to do in this particular section. I think that's just fine. Okay. So that is the end of section 7.4. Now, one thing that I've done here is I've went ahead and skipped section 7.5 for now. I may or may not end up adding that back in. It just depends on how I feel. That section is actually notoriously very hard, and I'm not sure if I want to give that particular section. That one's actually a little bit more difficult. So I may just I may let that section go as a thing. So there we are. All right. Do you guys have any questions at all? You're still, that's okay. That's fine. If you're still in 3.7, that's all good. 3.7's the toughest section, yeah. 3.7's one of the toughest sections. It is pretty tough. Yeah, let's not lie. It's true. It is a pretty tough section. No lie about that. Okay, if that's no questions, all right. So we're gonna end off here for today, and we're gonna come back on Wednesday, and we'll at least finish up the last section here of Chapter 7, unless I decide to do Section 7.5. But yeah, Chapter 7 will be finished for next class. All right. Yeah, absolutely. Please, by all means. All right. You have yourself a wonderful, wonderful afternoon and evening, and I'll see you in a couple of days, okay? Yeah, you have a great day as well, all right? Take care of yourself, okay? All right, everybody. I'm going to be heading out. Everyone, have yourself a very wonderful afternoon. I'll be back at 5. All right. Have a great one. We'll see you later. All right. Bye.